In this video, we're going to talk about a galvanic cell or voltaic cell. Now, to understand the galvanic cell, we need to look at this. This is a picture of a daniell cell. Now, in daniell cell, there are two beakers, each beaker containing two different solutions, and the electrodes are also made up of different metals. Now, for the anode, the anode is made up of zinc, and in this solution where the anode is, it's containing of zinc sulfate, and this zinc sulfate is in a molten state in this solution. And this is our cathode, and this cathode is made up of copper, and this solution where the cathode is, this solution is of copper sulfate. Now, there is a salt bridge here, and this salt bridge is made up of potassium chloride, and these two electrodes are connected by metallic wire. Now, if this solution is in its molten state, then they are already ionized. So this is zinc cation and sulfate anion, and in this solution is copper cation and sulfate anion. Now, what happens here is zinc, at this electrode is made up of zinc, right? This anode is made up of zinc. So here zinc donates an electron to this anode and joins this solution as a zinc cation. Now this electron flows up to this cathode here. It flows up to here. So the electron flow did occur, so electricity is passing. And now in this solution, see, the cation is the copper. Now copper goes to the cathode to accept that electron, and this cathode is made up of copper. Now copper accepts the electron and stays at a neutral solid zinc in the cathode. Now, why do we need the salt bridge? If the salt bridge was not there, this reaction would not last for more. It would not last more than 5 minutes. So, notice that in this solution, the number of zinc ion compared to the number of sulfate ion is increasing. So this solution is becoming more positive, right? And when the electron goes here and copper receives the electron and stays at the cathode as a neutral copper, the number of copper is decreasing, right? So this solution is becoming more negative for the sulfate. The number of sulfate is increasing because the number of copper is decreasing. Now, when this happens, an imbalance is created in both of these solutions. And for the imbalance, the zinc faces an obstacle to come to this solution. And if zinc does not come to this solution, electricity won't pass. And the same thing happens here, since the number of sulfate ion or cation increased in this solution, it do not let copper to go to the cathode. It attracts it towards itself. Now, what this salt bridge does is, since this solution have become more negative, the potassium gets ionized and joins this solution. It joins this solution, and the number of positive ions stays at a balanced state, and creates a balance between these two. And for the chlorine, so potassium as an ion went to this solution, and for the chlorine as an ion, okay, chlorine negative, chlorine as an ion joins this solution, and since this solution became more positive, chlorine joins the solution and makes it negative at a balance level, and balance is created here as well, and thus electricity flows. And since electricity is produced here, chemical energy is converted into electrical energy. Now, let's see what reactions occurred here. Okay, reactions in the anode first. In the anode, oxidation occurs. Let's say oxidation, okay? Zinc loses electron and becomes zinc ion, and then the electron goes to the cathode, and then in that cell, in the cathode, reduction occurs. Let's say red. So copper receives 2 electrons and becomes a neutral copper. So what's the total reaction? You just need to add up these 2 reactions. That is the total reaction. So the total reaction will be zinc plus the copper ion, which adds up to zinc ion plus the copper, and the electrons cancel out. So this is the total reaction which takes place in this daniell cell. Now notice that in this reaction we don't need any outer source of energy like we did in the electrolytic cell, and that's what the definition says. In the first video I've told you that the galvanic cell works. Okay, I've told you that the electrolytic cell works by an outer source of energy. All along we needed a battery, right? But in a galvanic cell we don't need any of outer source of energy. We don't need any battery. Here the reactions are taking place in these solutions, and these are producing the electricity. See you in the next video.